When you're solving a rational equation, you want to make sure that all of the denominators are the same. So your first step is to get a common denominator. In this example, they have a common denominator already. So once they have the same denominator, you're going to multiply both sides by that denominator to cancel it out. So I'm going to multiply this entire thing by x plus 2. So what's going to happen is the x plus 2's are all going to cancel. Okay, because I'm multiplying the left and the right side by x plus 2. What you're left with is just the top. So you're going to say x minus 1 equals x squared plus 2x minus 3. And then we're just going to solve this like a regular problem. So it's a quadratic. So we're going to bring everything to one side and set it to 0. So I'm going to subtract the x and add the 1. I'm going to subtract the x and add the 1. So now we have x squared plus x minus 2 equals 0. And now we're just going to factor. So what multiplies to negative 2, that adds to 1. So we're going to use 2 and negative 1. So x plus 2 and x minus 1 equals 0. So we're going to set both of these equal to 0. So if I set x plus 2 to 0, I get x equals negative 2. If I set x minus 1 to 0, I get x equals 1. So we have two answers. Now on the bottom it says you must check for extraneous solutions. So an extraneous solution is something that's not true to the original problem. So what you want to do is figure out what your restrictions would be. So our restrictions on the original problem would be taking the denominator and setting it equal to 0. So restrictions in this case is x cannot equal negative 2. If an answer is the same as the restriction, it's an extraneous solution. So x equals negative 2 is extraneous. Our only answer then is x equals 1. If we look at this problem, we want to find the solutions. So first thing we have to do is get a common denominator. Now the second fraction has a denominator of x squared minus 4. So we can rewrite that as x plus 2 and x minus 2. So I'm just going to cancel that out. So to make a common denominator, I need an x plus 2, top and bottom, and I need an x minus 2 over here, top and bottom. So we're going to distribute all the tops, and we're just going to write this as one big equation here. So we're going to say x times x, that's going to give us x squared. X times 2 is going to give us 2x. The second denominator here is x. We didn't do anything to that, so we're going to keep it as x. And the denominator is the x plus 2, x minus 2. So we're going to leave that. And then we're going to FOIL the right-hand side. So that's going to be x squared. Then we get a negative 2x and a positive 3x. So that's positive x minus 6. And then the bottom again is x plus 2, x minus 2. Because the denominators are the same, we can multiply both sides by x plus 2, x minus 2. And that's going to cancel everything out in the bottom. And we're left with just x squared plus 2x plus x equals x squared plus x minus 6. So we can combine like terms on the left-hand side and get x squared plus 3x. And then we're going to solve this. So if we subtract the x squared, they're going to cancel out. So there's no x squared terms. So now we have 3x equals x minus 6. So we're going to subtract x. So we get 2x equals negative 6. Divide it by 2. So x equals negative 3. Now if we check our restrictions here, our restrictions are, so restrictions would be that x cannot equal negative 2 or positive 2. So since x equals negative 3 is not one of my restrictions, that's going to be my answer. So x equals negative 3. Okay, if we look at one more, if we look at all three of the denominators, okay, they're not all the same. So I'm missing an x plus 4 from the first one, top and bottom. I'm missing an x plus 1 from the second one, top and bottom. And I'm missing an x plus 1 on the last one, top and bottom. So again, we're going to distribute the numerators. So I'm going to multiply x times x plus 4. So this is going to give me x squared plus 4x. I'm also going to distribute the 3 to the x and the 1. So that's 3x plus 3. And that's going to be over x plus 4, x plus 1. And then the second, the thing after the equal sign, we're going to FOIL. So we have x squared plus x plus 3x. So that's going to give us 4x plus 3 over x plus 4x plus 1. So since the denominators are now all the same, we're going to multiply everything by that denominator. So x plus 4 and x plus 1. They're all going to cancel out. And then what we have is, I'm going to combine like terms. So I have x squared plus 7x plus 3 equals x squared plus 4x plus 3. And then we're just going to solve this. So if you subtract the x squareds, they're going to be gone. So what we have now is just 7x plus 3 equals 4x plus 3. So if I subtract the 4x, I'm going to get 3x plus 3 equals 3. And now subtract the 3. So I get 3x equals 0. And when I divide by 3, x equals 0. And our restrictions would be what makes the denominator 0. And in this case, our restrictions are x can't be -4 or -1. So since 0 is not one of those restrictions, 0 is a good answer.